So today, my good learners, I am very grateful for what you are doing actually as we are having these classes together. I'm very grateful. Let me say I'm very happy and thank you to contribute to my channel, to subscribe, to like, and as well as to share. I'm very grateful. So just a quick review of what we did last time. A quick review of what we did last time. Remember last time we talked about the effects of heat on substances. Then we looked at what is likely to happen when substances in nature are subjected to different conditions of temperature, or when substances are subjected to heat. Then we looked at the changes that these substances undergoes, the changes that these substances undergoes when subjected to heat. And I remember, you and I remember that we mentioned that we only have two type of changes that happens when substances are being heated or when substances are subjected to temperature, high temperature of course. And these two changes are a temporary change and a permanent change. So yesterday we looked at a temporary change where we say that a temporary change is a type of change which is reversible and there is no formation of a new substance. We can be able to recover the original substance which we had. That's how we define a temporary change. Then I also remember we mentioned that we have two types of a temporary change, two types of temporary change, and these are the temporary physical change, which we talked about yesterday, and temporary chemical change. Now, just to, in a summary, to take you through a temporary physical change, this is a type of change which is easily reversible and there is no formation of a new substance. A temporary physical change is easily reversible and this type of change is there is no formation of a new substance. Now today, allow me to take you through the second types of a temporary change, what we call a temporary chemical change. So today we are talking about a temporary chemical change. It is still under temporary change. So the second types of a temporary change, we call it a temporary chemical change. Now, just a summary of what we are going to discuss, today. Now, the first one, we need to understand what is a temporary chemical change. We will look at what is a temporary chemical change. After looking at what is a temporary chemical change, then we will look at the substances which we can use to demonstrate a temporary chemical change. Then, of course, point number 3, at the end of the lesson, we should be able to write the word equations. The word equations that demonstrates a temporary chemical change. Word equations that demonstrates a temporary chemical change. Then finally, we will look at the characteristics of a temporary chemical change. Remember yesterday, we looked at the characteristics of a temporary physical change towards the end of that lesson. So today, we are going to do a similar of what we did yesterday. Towards the end of this lesson, we will talk about the characteristics of a temporary chemical change. That's right. Now, it is a temporary, pen is not writing, it is a temporary chemical change. I want you to underline to underline this word here, chemical. Underline the word chemical. Then a temporary chemical change. The key word here is chemical. What do we mean by a temporary chemical change? This is a type of change that interferes with the chemical composition of substances. A type of change that interferes with the chemical composition of a substance. Remember, just to take you back, in a temporary physical change, the change does not interfere with the chemical composition of a substance. It only leads to alteration in terms of size, shape, and maybe structure, but it does not interfere with the chemical composition of a substance. Now, in a temporary chemical change, the chemical composition of substances are changed or are altered in one way or the other. That's why we refer to it as a temporary chemical change. Let me move to our summary number 2. What are the sum of the substances we can use to demonstrate a temporary chemical change? At our level here, we are only going to use 2 substances here. And the first one, let me write here, the first one we are going to use hydrated copper 2 sulfate. Hydrated copper 2 sulfate. And the other substance which we are going to use here to demonstrate a temporary chemical change is, so the second one, hydrated cobalt 2 chloride. So the 2 substances which we are going to use here to demonstrate a temporary chemical change, we have hydrated copper 2 sulfate. Then also the second substance here is hydrated cobalt 2 chloride, right? I want you to underline the word hydrated. Underline these words because they are key to what we are going to discuss after this. So the 2 substances, hydrated copper 2 sulfate and hydrated cobalt 2 chloride. These are the one we are going to use to demonstrate a temporary chemical change. When you look at these 2 substances are chemicals, right? Good. Now we need to ask ourselves, what is the color of these substances? The original color of these substances. So the original color of hydrated copper 2 sulfate is blue. Let me write here blue. The original color of hydrated copper 2 sulfate is blue, while the original color of hydrated cobalt 2 chloride is pink. The key area to get is to understand the color of these substances. The original color of these substances. Hydrated copper 2 sulfate is blue in color. Then hydrated cobalt 2 chloride, it is pink in color, the original color of these substances. Now, what happens when we heat hydrated copper 2 sulfate? And what happens when we heat hydrated cobalt 2 chloride? Very simple. You don't have to stress yourself. Just take hydrated copper 2 sulfate in a boiling tube, hold it with a test tube holder, then begin heating. Then observe what is likely to happen. Now, these are the observations that we are likely to make when we heat hydrated copper 2 sulfate, which is blue in color. So let me write here, hydrated copper 2 sulfate what happens when we heat hydrated. So we use an arrow here indicating heat. Heat. Now let me say this. When you heat hydrated copper 2 sulfate, a white powder is formed and the colorless liquid is also formed. Those are the two observations that you are likely to make when you heat hydrated copper 2 sulfate. Observation means something which you are able to see with your eyes. So I'm able to see a white powder at the end of heating. I'm also able to see the colorless liquid after heating. Now, the white powder formed when we heat hydrated copper 2 sulfate, it is called anhydrous copper 2 sulfate, right? Then the colorless liquid in this case is water. So let me write the equation. Hydrated copper 2 sulfate, which is blue in color, when we heat it, it forms anhydrous. It forms anhydrous copper 2. It forms anhydrous copper 2 sulfate. Copper 2 sulfate plus water. It forms anhydrous copper 2 sulfate plus water. So this is white in color. Then this is what is colorless. Now, the second question which we need to ask ourselves, why is it that when we heat hydrated copper 2 sulfate, it forms a white powder and a colorless liquid? Now, this is what happens. The word hydrated here means that copper 2 has water in it, right? And this type of water, we call it water of crystallization. Sawa sawa. So hydrated means it has water. Now what happens when you heat a substance that has water in it is particles? Now look here. If we heat hydrated copper 2 sulfate, it loses water. As it loses water, it forms a white powder. And the name of this white powder is called anhydrous copper 2 sulfate. Then the water that was lost during heating, it is collected as a colorless liquid. Right? Now, explanation for this is very clear. When we heat hydrated copper 2 sulfate, it loses water of crystallization. It loses water of crystallization to form anhydrous copper 2 sulfate, which is white in color, to form anhydrous copper 2 sulfate, which is white in color, plus the colorless liquid. Are we together? Let me repeat for clarity and maybe to enhance understanding among my learners. What happens when you heat hydrated copper 2 sulfate? Hydrated copper 2 sulfate contains water. And this type of water, we call it water of crystallization. So when you heat hydrated copper 2 sulfate, it loses water of crystallization to form anhydrous copper 2 sulfate, which is white in color, and the colorless liquid. That's why at the end of the experiment, you'll be able to observe the white powder and a colorless liquid. Let me repeat this. When you heat hydrated copper 2 sulfate, it loses water of crystallization to form anhydrous copper 2 sulfate, which is white in color, and the colorless liquid. Sawa sawa. The blue color in hydrated copper 2 sulfate is because it contains water. The white color in anhydrous copper 2 sulfate is because it lacks water. Sawa sawa. Now, let's see what is likely to happen in hydrated 2. Let me use a different pen here. A different pen. So this is hydrated cobalt 2. Hydrated cobalt 2 chloride. So heat. Then we have anhydrous cobalt 2 chloride plus water. Now, we said that the original color of hydrated cobalt 2 chloride is pink. Now, what happens when you heat hydrated cobalt 2 chloride, which is pink in color? In the same way, hydrated copper 2 sulfate changed from blue to white is what is going to happen here. So when we heat hydrated cobalt 2 chloride, remember the word hydrated means it has water in between the particles. Now when we heat hydrated cobalt 2 chloride, it loses water of crystallization to form anhydrous cobalt 2 chloride, which is blue in color, and a colorless liquid. And this colorless liquid is water. Let me repeat to enhance understanding. Hydrated cobalt 2 chloride, when it's being heated, it loses water of crystallization to form anhydrous cobalt 2 chloride, which is blue in color, and the colorless liquid. Right? Now, these are the two substances we are using to demonstrate a temporary chemical change. Now, let me stand this side and repeat this. A temporary chemical change is a type of change that interferes with the chemical composition of a substance. We are using hydrated copper 2 sulfate and hydrated cobalt 2 chloride to demonstrate a temporary chemical change. The word hydrated here means these substances have water in their particles. And this type of water, we call it water of crystallization. Now, what happens when you heat these two salts? In fact, we call them salts, hydrated copper 2 sulfate salt and hydrated cobalt 2 chloride. When you heat this salt, they lose water of crystallization. Zinapoteza maji of crystallization. So hydrated copper 2 sulfate loses water of crystallization to form anhydrous copper 2 sulfate, which is white in color, and the colorless liquid, right? Now, also, hydrated cobalt 2 chloride, when it's being heated, it loses water of crystallization to form anhydrous cobalt 2 chloride, which is blue in color, and a colorless liquid, right? Now, the next lesson we're going to see to talk about the characteristics. We've already talked about the substances, so talked about the word equation. These two are examples of word equation. In an exam, when you are asked to write word equation, when hydrated copper 2 sulfate is heated, it is here. You write hydrated copper 2 sulfate, you indicate the color, arrow, you show that it's being heated, then you write anhydrous copper 2 sulfate plus water. Then don't forget to indicate the color of anhydrous copper 2 sulfate. Now this is the word equation for hydrated cobalt 2 chloride. Hydrated cobalt 2 chloride, which is pink in color, arrow, heat, we get anhydrous cobalt 2 chloride, which is blue in color, plus the colorless liquid, which is water. Thank you very much. Thank you for your time.